0.1. For digital device force sensor, we always use positive or negative, the smallest digit. So here we have 19. If you look at this one, 19.16. So the smallest digit, look at the decimal place, it's going to be 0.01. For not necessarily, we always use this rule when we calculate the uncertainty, because method also will influence the uncertainty. So it is better to use your judgment rather than always using this simple rules. For digital device, we use in class the value jumped between 1 point, the value jumped between around 1.07 and 1.09. So the uncertainty, if you take the difference between these two values, is 0.02 in Newton. So we're going to take this value, and it's really important to state how you arrived this value in your lab report or even your IA. So that's why we record the value here of uncertainty 0.02, and the unit here is in Newton, not centimeter. Okay, so all of them should be in Newton. In Newton, we have a mistake here. We have to correct this mistake. Newton. So uncertainty for the ruler, positive or negative 0.1. Uncertainty for the force, positive or negative 0.2. So the first value is 1.7. If we add 2, it's going to be 1.09. If you subtract 0.02, it's going to be 1.05. So the value is between this range. Now we have to find the average. To find the average, all you need to do is just let me clear this content here. So I'm going to write equal, start with the word F and choose average, and then select all the values of these forces, close the bracket, and then hit enter. And put the mouse on this value. You will find here like dot on the lower right corner. You put your mouse on it till your mouse turns like a plus sign, and then drag it all the way down. Now we need to find the uncertainty. For uncertainty always, since we repeat the experiment different like 4 times, so the formula for uncertainty is going to be the maximum value minus minimum value divided by 2. So I'm going to write here equal. I'm going to type the word max. Okay, double click on it before we have to open bracket first. Okay, double click and select the values of these forces. I have 4 values, so select them all. Close the bracket, minus minimum. Okay, so I typed min, double click on this function and select all the forces, close the bracket, divided by 2. Same thing, drag this value all the way down. Now, we need to draw the uncertainty. Now remember, to draw the error bars, as we learned in the class, I have X, which will represent our independent variable, and Y, which is the dependent variable. X is our extension, so X is our extension in centimeter, and Y, which is F, our force in Newton. We'll take the first and last value. So the first value is 1, last value is 6. The average value for force is 1.07, and the last value for force is 4.38. So we're going to draw these values here. So the first value, it's 1. And the last value here is going to be 6. Here, we will take y. Y is 1.07. And the value for the last value for the average value, the average value for forces, so 1.07, the first one, and the last one is 4.38. 4.38. So this is our first value, and this is going to be our last value. These are our points. Now we need to draw error bars. Now, in order to draw the error bars, we have fixed error bars on x-axis, which is 0.01, the uncertainty of the ruler. So if I need to add here 0.01 from both sides. So if I add 0.01, this point is going to be 1.1. And if I subtract 0.1, this point, it will be 0.9. Same thing for the other point. If I'm going to add, this is the horizontal error bar. So this point here is going to be 6.1 and subtract 0.1. So this point will be 5.9. I need to draw now the vertical error bar. Now, to draw the vertical error bar, if we go back, the first point, the vertical error bar is 0.03. And the last point, the uncertainty, 0.06. So I have to go up the first point, which is 1.03. So if I go up 0.03, I'm going to draw it with different color. I'm going to go up and down 0.03. So if I'm going to add 0.03, so this value here, it will be around 1.13. And this one here, it will be around, if I subtract 1.07 minus 0.03, it will be 1.04. 1.04. Now, for the other 0.6, we said we have to go up the uncertainty 0.06. So if I go up, if I go down 0.6, the original value is 4.38, subtract 0.06, subtract 0.06, so 4.38 minus minus 0.06. Okay, so this value here, this one, it will be 4.32. And if I go up 0.06, if I go up 0.06, so 4.38 add 0.06, it will be this value, it will be 4.44. And this is, let's write it here, 4.32. Now, to draw the error bars, complete this shape, make it as a triangle shape. So I'm going to have to complete it. I have to complete this shape, and I'm going to complete this shape. Now, for the uncertainty, the error bar, we have to draw maximum and minimum error bar, maximum and minimum lines. So for the maximum line, always join the bottom right corner this point here at the bottom right corner, this point, with the left-hand corner, with this point here, with this point. So this will be our maximum slope. For our minimum slope, I'm going to change just the color. For our minimum slope, we have to draw the top left corner, the first point, with the bottom right corner here, this point. So this will be the minimum slope. Now, the coordinate for this, we have to write the coordinate in order to find the slope. So the coordinate for this point, this is going to be 1.1, and this is x-axis, and y-axis is this one, this value, which is 1.04. 1.04. So it will be 1.04. And for this point, x-axis is 5.9, and y-axis, I went up 4.44. 4.44. So how can we find the slope? Always change in y divided by change in x. Okay, now for the minimum slope, this point, the coordinate of this point here is 1 point. I'm going to write it here. 1.1, and y-axis, as I went up, it's going to be 1.13. So it will be 1.13. And this point here, x-axis is 5.9, and y-axis, I went down, so it will be 4.32. Now to find the slope, to find the slope or the gradient, it's going to be delta y divided by delta x. So if I need to find the maximum slope, Excel can do that, but I have to explain it first, and then we can I'll show you how to use Excel. So we need to find the maximum slope, delta y divided by delta x. I will take the green line, So delta y in the green line, I'm looking at this point and that point. So it will be 4.44, this is y, minus 1.04 divided by delta x will be 5.9 minus 1.1. Similarly, for minimum slope, we'll take this point here in pink with this point. So same thing, delta y over delta x. Delta y, it will be 4.32 minus 1.13 divided by delta x, change in x 5.9 minus 1.1, and then you find the slope. How can we let Excel draw these lines for us? So we'll go here. I have to make the steepest line for x extension and steepest line for y-axis, the force. So for x, we said, remember, we need this point, which is 1.1 on x-axis, and the value for y, it will go down. To go down the value of uncertainty, which is 1.04. So for x-axis, we have to add 0.01. So we'll go back here. This is the first value. So it will be this value plus 0.1, plus 0.1. And we said for y-axis, you have to go down this value, you have to go down the value of uncertainty in F. So you need to go down. So it will be the value of this force minus the uncertainty. So minus this value. Hit enter. Okay. Now let's go back to the same point. This point, we're done with this point. Now we'll go to the second point, which is the last point. Now the last point here at the left-hand corner, x-axis, it's 5.9. What did we do? We take the value of x minus the uncertainty. So we go back here. This is the last value. This is the last value. So it will be 6 minus the value of uncertainty, which is 0.1. Now for y-axis, we're talking about still this point on the green line. So the uncertainty, the y-axis, it will be the value of this force plus the uncertainty because I'm moving up. So it will be plus the uncertainty. So I'm going to go here, equal average value of F plus the value of uncertainty. Now we're done with the steepest line. Let's go now to the least steep line. I'm going to start with X and then we'll go to Y, the first point. Now remember, the first point, least steep, this is the blue line. The first point, it will be 1.1. What did we do? We take the extension plus the uncertainty, So we'll go here. So it will be equal the value of X plus the uncertainty, which is 0.1, and hit enter. I need y-axis. Let's go back again. We're still in the blue point. Y-axis, I'm moving up. So y-axis, the value of the average force, I'm moving up. So it's going to be plus the value of uncertainty. So this value equal the value of F plus the uncertainty. Now we'll go to the last value, which is 6. Now 6 here at the bottom right corner, it's the value of X is 5.9. So that means I took the value of the extension, which is X minus the uncertainty. So it will be equal this extension minus the uncertainty. Hit enter. And for Y value, we're talking here about this point. So I took the value of this force, I'm moving down by the value of uncertainty. So I should get 4.34. So it will be equal the value of F, the average force, minus this value of uncertainty, and then hit enter, which is 4.32. Now we need to draw the error bars. To draw the error bars, I'm just gonna highlight or select any column. I'm gonna hit insert, and we choose scatter plot. Okay. Now for the scatter plot, right click on any point and then select data. I'm going to edit this data. I'm going to call it force versus extension. And we said x-axis should be the extension. So I will go and select x-axis. Y-axis will be the average force. So go here and select the average force. Okay. Okay. I can click on this plus, or you can add chart element from here. I'm going to add primary horizontal axis. I can add vertical axis. So you have to write, this is what is extension. So it's going to be extension. Write the unit. We use centimeter. And this one here represent force, and we need to write the unit, which is in Newton. Right click again. We can select add a trend line and display the equation. Choose this one and display r squared. This to tell you how accurate our variable, if it's close to 1, or if it's close to 1 is going to be more accurate, of course. More we have correlation. So this is the value of the slope, and of course the slope will represent the spring constant, which is 0.65. Now still I need to add error bars. So I will right click here again and go to add chart. You will have here error bars, standard error bar selected. Now go to the horizontal error bar selected, and we set the horizontal is extension and the extension is fixed. So I'm gonna click on fixed value, and this value is 0.1. So I'll keep it 0.1. Go to the vertical error bar selected, click on vertical error bar and go down here, choose custom, and then specify value. The value, you have to make positive and negative. So we'll go here, select the uncertainty in y direction, which is force, and go down. For the negative error bar should be the same. So I will select also the same values. Hit OK. Now we have the error bars here. Okay, we need to add also steepest and least steep lines. So we're going to go again here, right click, select data, and I'm going to add. Now this time I'm going to call this one the steepest line, and my x-axis for steepest line, it will be this one, the extension steepest line. I'm going to select these values. For y value, it will be the second column next to it. Second column, this one. Okay. Okay, and again, right click on this point and choose add a trend line. Go down, display the equation there. So I'm going to put in the middle the original equation of the line. On the top will be the maximum slope, the steepest line. Still, I need the least steep line. So right click again, select data, add, and here I'm going to call it least steep line. X value for least steep line, it will be this one, this column. So I'll select this one. And y value, it will be this one. Okay. Same thing, right click on this point, gray point, and add a trend line. So I'm going to select this point. Yeah. I'll try to figure it out. Anyway. Now here is my highest or my steepest line, the slope here. And this is the least slope line. You just make it bigger so you can see the values. Okay, and the steep slope line is here. And this steep line is here. Till now we haven't done, because we need to write the value of K. So the value of spring constant, we know Hooke's law, F equals K times X. So this one is y-axis and this one on x-axis, so the slope or the gradient will be K. This will be the gradient or the slope. Now what will be the value of the slope is this one. So this is K. So the value for K will be 0.6583 Newton per centimeter. You have to write the unit. Newton per centimeter. Now we need to have to write the uncertainty in K. Now for the uncertainty in K, we know it's maximum slope minus minimum slope divided by 2. This is the uncertainty in K. So maximum slope, the value of the maximum slope is this one. And the value of the minimum slope is this one. This one here, it will be the uncertainty in gradient, maximum, minimum, and the uncertainty in y-intercept, sorry, the uncertainty in y-intercept. So first we have to find the uncertainty in the slope. So maximum is this value. This will be minimum. How can we find the uncertainty? Just subtract these values divided by 2. So it will be the first one. I need just more space, so I'm going to delete this one. Okay. So the uncertainty in the gradient or spring constant will be maximum, which is 0.7094 minus the minimum value, which is 0.6698 divided by 2. And if we calculate this one, 0.7094 minus 0.6698 divided by 2, it will be 0.02. Always round the number to one significant figure for the uncertainty, 0.02. So when you write the spring constant, it will be from the slope, this value, K, always when you write it K, positive or negative, the uncertainty. Okay, so it will be 0.65 positive or negative 0.02, positive or negative 0.02 in Newton. Don't forget, in Newton per centimeter square. Newton per centimeter square. Newton per centimeter square. You have to write the unit. Now for the y-intercept also, you have to write the value of y-intercept, positive or negative, the uncertainty. So for y-intercept, as we've done here before, the value of y-intercept is let's just erase this one. It's going to be y-intercept. So this value, which is 0.4368. Now, positive or negative, the uncertainty. Uncertainty, it will be this value minus this value divided by 2. So it will be 0.3632 minus 0.259 divided by 2. Then you record the value of the uncertainty. That's it. This is how you do the calculation in your last lab report. Please keep this video for your reference, as you will need it when you do the rest of